as well. So both Mars Odyssey and the Mars Reconnaissance Orbiter are going to provide telecommunications service for Phoenix, just like they do for Spirit and Opportunity currently. Now, Phoenix isn't going to last as long as Mars exploration rovers. It will not be there to greet Mars Science Laboratory when it lands in 2010, mainly because of the environment. That close to the northern polar region, the sun is low on the horizon, it's going to get very cold, and the power levels are going to get low as we get later into the calendar year. But nonetheless, there'll be an enormous amount of science to do, and it'll be very exciting. As you can see also from this graphic, Phoenix fits in between orbital reconnaissance through the Mars Reconnaissance Orbiter, and also fits prior to the Mars Science Laboratory. So it's in a very nice location to help us with Follow the Water theme. So this is great. As I said, Phoenix is going to touch it. This is very exciting in that regard. Very important addition to the Mars exploration strategic goals. So stay with us as we dig deeper into the history of the red planet and understand the water cycles and the potential to currently or in the past harbor life. Very exciting. Peter is going to now talk to you more about the science of this mission. Peter?
Thank you, Doug. The 20th century started off with a race to the South Pole between Amundsen and Scott. And since that time, we have been studying the polar regions in great detail, and there's two major things that we have learned about the polar regions. One, they are very strong indicators of climate change. Not only current climate, as we watch the polar caps receding and the glaciers speeding up as they tend to be melting and moving towards the ocean, but also ancient climates. We can go back almost 500,000 years from cores taken through polar ice and try and understand the history of our planet. The other thing is that the polar region is a great preserver. Just as in your kitchen you preserve your food in the freezer, so the planet preserves organic materials and the history of life on this planet inside of the ice in the polar regions. Now we're in the 21st century, and we're beginning this century with a mission to the polar regions of Mars. This may be just the same kind of springboard into the science of Mars that Amundsen and Scott's mission was in 1910. We have lots of goals in mind as we go to the polar region, but number one is finding water ice and trying to understand the hydrologic cycle that brought this ice to the Martian northern plains. And it's through this exploration that we intend to also uncover the weather that is the polar weather on Mars, which should be quite exciting. And to kind of give us an idea of where we're going on Mars, my first video will show us flying across the Tharsis volcanoes of Mons Olympus and Albopatera, sweeping down off the high pinnacles of these volcanoes down across the northern plains to where the polar cap is just seen in the distance, and there's a little green ellipse down below, and that is our landing site. Not on the permanent ice, but nearby in what is a permafrost region in the northern plains of Mars. What in the next slide, we can see why we think this is such an important place. This is a map of the near-surface water on Mars taken by the Odyssey spacecraft, a map made through the use of detected gamma rays and neutrons that are emitted from the surface of Mars because the surface is impacted by primary cosmic rays and acts a little bit like an MRI machine is seen inside of your body in the hospital. So we can see actually to depth in the surface of about 1 meter, 3 feet. And the colors here represent the amount of water. In the equatorial regions between 0 and plus or minus 60, we see that the water is less than about 8% in the soils, and it's probably bound water. In other words, it's attached to clays and various salts. But in the polar regions from 60 degrees north and south, there's a very large abundance of water, and it's almost mixed between, say, 30 and 60% water to ice, ice to soil ratio. And so we expect a tremendous abundance of ice in these northern plains. And in fact, our landing site, shown by the dot on this screen, is in the highest concentration of ice outside the permanent polar caps. The next slide shows where we are on a topographic map. Now the colors here represent altitude. And you can see the volcanoes to the left of this screen, and the three of them lined up are the Tharsis volcanoes. To the left is Mons Olympus. A little higher is Alba Patera. And way on the flank of Alba Patera, at 68 degrees north, you see where Phoenix is landing. This is quite different than the two Vikings, the Pathfinder, Opportunity, and Spirit. They are landing in the dry regions of the equatorial zone. And these dry regions are places where we can expect to discover the ancient history of Mars as written into the rocks. And in fact, that's what the rovers are doing today, is looking inside rocks to try and understand what the environment was like in ancient Mars times. And of course, what we're finding is it was very wet in those two locations. Phoenix is doing something quite different. By landing on the ice in the northern plains, we're looking at active processes that are taking place today. And these active processes have to do with the expansion and contraction of that ice throughout the seasonal changes. We're going to see climate change written into the soils because of the tilt of the spin axis. And when that axis tilts, and we know it does, to the point where it's almost pointing at the sun, we can expect an opportunity where the ice might actually melt to liquid water and change the properties of the soil, change the chemistry of the soil, change the microscopic properties of the soil, all of which we'll be able to detect. And our highest goal is to see if this creates a habitable zone on Mars where we might find organic materials, we might find the presence, at least periodically, of liquid water, and we might find chemical energy sources. The next slide shows that if we went to Earth at this same location, where would we land? And this turns out to be in northern Canada, not far from the polar seas, the Arctic Sea, and a place where we know there's permafrost on the surface, and we see expansion and contraction of the ice near the surface. We know that in the summer this is a very biologically rich location. However, it's not really Mars-like because of the wetness of these soils. And in fact, in the next slide, we show a comparison is better made between the Martian northern plains, as seen to the left in winter, where you see lots of little tracery with white lines, and that's places where ice is in more abundance on the surface. And we can compare that with Antarctica, which is much drier and much colder, and we see the same kind of cracking of the surface. So because of the similarity of these two processes, we can study Antarctica and think we're kind of halfway between the Arctic and Mars in Antarctica. Mars is much drier, much colder, and we expect to find different signatures on the surface because of this. So the science we plan to do is very exciting. It's likely to be sort of a course change in studying Mars because the polar regions are where we can understand recent processes, climate change, the potential of habitability, but not finding life because there's no signpost today that tells you where to land and that will be life. So we're taking a chance. 25% of Mars has this sort of polygonal terrain, and so it's really studying a large portion of Mars. And to tell us how we found a landing site among this huge region is my colleague, Dr. Raymond Arvidsson, who has led the landing site working group and will tell us about our landing site.
Thank you, Peter. Finding a place to land that was scientifically interesting and safe in terms of not too many rocks and relatively low slopes. It's been a multi-year, very challenging process. The northern plains of Mars are flat. They're fairly smooth. Slopes are not a big issue, but they have lots of rocks. And it's almost like farmers' fields in New England, where the ground is processed by being